Hello everyone. Today in our session we will discuss production function, and we will largely first we will discuss about the general concepts of production function, and then we will try to connect them with the healthcare or healthcare operations. Now, the theory of production is basically a part of theory of the firm, theory of the firm. Now, firm is a production unit. Yeah. So, when a firm decides to produce something, it has also a cost implication. When we talk about our demand, our resource constraint and our efficient choices, we have to connect all of them together when we discuss about theory of the firm. Let us understand that we have, say we have a hospital system where we have limited number of doctors and plenty of patients. So, there is a limited supply, there is a constraint in terms of resources, in terms of doctors, nurses and other resources what we generally see in any public hospital in India, but the demand is enormous. Having said that, there is a cost implication, that the cost can be again monetary and non-monetary. The cost of the treatment as well as the other non-monetary costs, that there should not be any high prevalence of diseases or no mistreatment as far as that death can be avoided. So, the optimization is primarily is cost minimizing. The optimization in theory of firm is basically cost minimization process of production considering various input bundles. All right, this is our, these input bundles are our will determine that how my production will take place, or given the different input bundles what can be the optimum production. Now, having said that, this production in a firm can be obtained by production technology, number one. Number two, cost constraints, that is basically the budgets I have been given, that within this budget I have to produce whatever I want to produce. So, even if I have the supply of input, I cannot probably in a primary health center I cannot probably keep 5 doctors and 15 nurses. Yeah. So, I have a budget constraint for each primary health center, for each hospital, for each say public health awareness campaign, everything if we consider as individual production process, because everything has an outcome, everything has a production process, then there is a cost constraint, there is a budget constraint, that whatever I need to do, there has been stated already that this is your budget, within this you have to manage the entire operation. So, that is the cost constraint. So, even if I know my production technology, I can avail the technology, but having the technology I have been given that this is your technology, this is your cost constraint, and based on that I will decide my input choices. They are the production factors or factors of production, my input choices, that which will be the how many capital, how many labor, which kind of labor, which kind of capital, which kind of machinery, what will be the other ingredients in in a production process, whatever is required I have to decide based on the budget I have been given my production technology. Therefore, production function. Now, the theory of firm deals with both the theory of production and theory of cost. So, a production function can be stated as Q, that is the quantity of production, amount of production, as a function of K, which stands for capital, L, which stands for labor. K basically is non-human capital and L is the human capital. Yeah. So L is labor, K is capital, but we must state given the technology. So technology is assumed to remain constant during a production process given the technology. So production or my output is a function of the capital and labor, the different combinations of number of capitals and number of labors, and the goods and services, the production of the goods and services will depend upon that. Why goods and services? Again, as I said, when I take the example of a hospital service, no, so it is not actually I am getting treated, it's not actually a good, it's the services I am availing. Wherever I am going to a shop or a pharmaceutical organization, manufacturer, they are manufacturing goods. So goods and services both can be treated as an outcome of a production process. When I float an awareness campaign program, say on HIV/AIDS, it's a service basically, and the outcome is the awareness among people about HIV/AIDS. Yeah. So and that awareness generation about HIV/AIDS depends upon how much capital I am putting in, as well as how many labor forces, who are those labor forces working towards this awareness generation program. So a production function depends upon time period, right? For how long I will be producing, or now given a time period I have certain constraints. Let us see what is time period. There are two types of time period or two types of production function given time period. One is short run decisions in terms of production. One is long run decisions. Yes. Now what is short run? In short run, it's not, I cannot say that it's 1 day, it's 1 minute, it's 1 month, it's 1 hour or 1 year. There is nothing like that, that a short run should be a short period of time. No, there is nothing like that. A short run is a time period where I cannot adjust all the processes or all the factor inputs. I cannot vary all of them, which has a direct implication on cost. Yes, so in short run I have a limitation. So let us take a simplified example. When we have a 2-factor production unit that I have just 2-factor inputs, one capital, one labor maybe, and if in a short run I cannot change both these factors of production, I will change only one of them. I will only if it is possible. That's primarily, say suddenly there is a mishap in my locality where my hospital is there, and I have to treat up, there is an inflow of patients, say 50 patients suddenly come in. Now what do? I cannot get the number of doctors, suddenly I cannot increase the number of doctors. I cannot increase the number of nurses suddenly. Maybe what I can do is that I can ask for some volunteers. If I have a medical college in that hospital, I can ask some medical students to pitch in. I can take help of some blood banks or some other medical equipment supplying agency who can provide me at a very emergency notice that they can provide me certain basic minimum or basic necessary healthcare requisitions, yeah, healthcare or treatment commodities. Now, so that is the short run. It can be a 1 day, even a short run can be 1 year if it's a large production process, yeah. Whereas in long run, so in short run I can only change the cost or I can only vary the cost based on either very few in a multi-factor units, in a very few of these factors of production, or else I can just change the production process, that's all. Where in long run I have enough time in my hand so that all the factors of productions are variable. All the factors are variable. So I can change it according to my wish. I want to change in that particular hospital, I want to change next year maybe 50 new beds I want to introduce. I can do that. I can sanction a budget. I can kind of do a predictive modeling that what has been in the last year and what can happen in the next year, whether I am seeing an increase in demand, whether I can see the prevalence of certain ailments in that particular locality. I can open a new discipline, maybe orthopedics, maybe neurology, maybe oncology. So all these things I can do. And to make all these changes, the basic necessary time, the minimum necessary time I will require, that can be considered as the long run, and there onwards any time period can be our long run. So now, after stating my production function Q as a function of capital and labor, given technology, I don't have to mention this all the time, but we need to keep it in mind. Yeah, given technology. So Q stands for total output, K stands for total capital, L stands for total labor. Together that capital and labor is giving me an output of that amount of Q. Therefore, as we can go back to arithmetic mean or average, my average production, which we can say AP, average production or of labor, which can be stated as output per labor or per unit labor. Yes, APL can be stated as total number of output divided by total labor. So total product divided by total number of labor, which is required to manufacture that many output. Similarly, average productivity of capital can be total product divided by total number of capital. So total product divided by total number of labor required to manufacture that amount of product. Similarly, over here total product divided by total capital. This is the average product of labor and average product of capital. It can be the total number of patients being served or treated by one doctor in a particular district, in a particular state, in a particular primary health center. Yes, so total number of patients in a particular time period divided by total number of doctors. Yeah, that is the average product of that doctor. The next concept is marginal product of input. I can keep it as labor. Marginal product of labor. I can write it like MPL, marginal product of labor. Now this marginal product, again, if we go back to our marginal utility concept, marginal is incremental. Yeah, how to remember it? When we talk about marginal utility, we talk about change in utility. Then we think why utility is changing, because of consumption of one extra unit of a particular commodity. Similarly, here marginal product of labor, again marginal is associated with which word? Product. So that is incremental change or the total change in the total product or total production, total output, by why output changes? Because of the inputs, either because of capital or because of labor. So total change in capital or total change in product by one unit change in either in labor or in capital. So we can state it like delta Q, or marginal product of labor is delta Q by delta L, whereas marginal product of capital can be stated as delta Q by delta K. isn't it? So that is the, again I will repeat it, that marginal product, change in product of, when I say labor, that means change in product because of 1 unit extra labor. Similarly, marginal product of capital is change in total product because of 1 unit extra capital. So that is my marginal product of labor and marginal product of capital. So it says us, when we hire or recruit one extra input, be it labor or capital, what is its implication? How much is it returning towards my production, total product? Yes, and then I can have an idea that whether we will go on increasing more and more labor or capital, or we will stop at a particular point of time. Yes, because my budget has a limitation and I will have to make an efficient choice. I cannot take too many labors or too many capitals. We will learn it now. Say, let's take a very simple table. Yes, and then we'll go how this average product or marginal product behaves. The simple table here will take amount of labor. Let's take it as 0, 1, 2, 3, 4, 5, 6. Amount of capital. Amount of capital, will keep it fixed. It's a short run production function, and 2 input production function, 2 factor. Total product, which is basically our Q, is, this is our L, this is our K. Total product is, say, 0, 100, 250, 350, 400, 400, 380. Yes. So what we see, let us first calculate the average product, or APL, average product of labor, APL. I won't do average product of capital because nothing is changing essentially. Yeah? Everything is similar, but we still can calculate 0 by 10, 100 by 0, 250 by 10, but here capital doesn't really make sense. That's primarily because labor is a variable factor. When I try to compare with different scenarios with different number of labor, I will look at the labor, because that's where I am changing my decisions. And over here I will keep marginal product of labor. Yes. Now so average product over here is 0 because anything it doesn't really make sense, 0 by 0. The amount of labor over here is, average product is 10 by 1, 100 by 1, 100, right. Over here 250 by 2, 125, 350 by 3, it should be 116.7, 400 by 4, 100, and so on, 80, and it should be something like 63.7. Yeah, or 0.3. Yeah. So the marginal product, again here it really doesn't matter. So when I don't have any labor, I incorporate the first labor. So again, if you go back to the marginal utility class, here I will do delta Q by delta L. It's basically delta Q by delta L, and this delta Q by delta L is basically you know, 100 minus 0 by 1 minus 0, isn't it? Because I am incorporating one extra unit of labor and my total product changes from 0 to 100 when my labor increases from 0 to 1, keeping the number of capital same. Therefore, my marginal product of labor is 100. You can also do it 100 minus 0 if there is the changes is 1 unit, you know, every time. Over here it's 150, 100, 50, 0, minus 20. Yes, so 100, 150, 100, 50, 0 and minus 20. Let us see how it really matters, you know. So going to the, if I plot them graphically, I can see that the total product, generally I am not plotting this particular graph, but at the, you know, it is universally same. So when I plot a total product curve, over here you can see it increases, right? 0 to 100, 100 to 250, 250 to 350, 350 to 400, 400 it remains constant and then it comes down to 380. That means it is increasing. Initially it is increasing at a very fast rate, and then it, you know, when we look at the marginal productivity, we can see if it has increased by 100 units, 0 to 100, then 100 to 250, again at a faster rate, and then 250 to 350, the rate slows down, but it is increasing. 350 to 400, it is increasing, the rate is slower. 400, it doesn't increase anymore, and then 380. We have a proverb in probably all the languages. I will just take the English one. Too many cooks spoil the food. Yes, so here we have seen that when we kept on increasing the number of labor, the production finally went down. So we have to decide till which point we will continue our production process. Very nice. So when we plot total product curve, when we plot a total product curve, over here output in a given total product in a given period of time, and over here you will mention your input, labor or capital, whatever. So initially it increases at an increasing rate, So dy dx is, you know, the first order derivative is positive, the second order derivative is also positive, d2y dx2. So it is increasing at an increasing rate. Next it continues increasing but at a decreasing rate. You can see it is increasing at this phase but at a decreasing rate. At a certain point it is being stagnant and then it comes down, right? That's what we saw here. It is increasing at an increasing rate, first 100, then 150, then it started falling down, 100, 50, increasing 0, and then it decreased to 400 to 380, right? If we take a very simple example, you know, say production of a bike. I have got a new bike. So the mileage when I buy a new bike, it's not really high, you know. So but it increases at an increasing rate. But after a certain year, with its depreciation, the mileage probably increases, but then it increases at a decreasing rate. And then after a certain while, when it's old, the mileage starts falling. Yeah, so it can be visible in all production process almost, yeah, across the world. Now, therefore, this is my production process where you can see by the slopes are steeper and it starts getting flatter. At this point, it's stagnant and then it's decreasing. Yes, so it's decreasing here. Anyways, now if we want to plot the average product curve, how does it look like? An average product curve, if you see here, it again increases 100 to 125 and then it falls, right? 125 to 116.7, 180, 63.3. But even if the marginal product goes to negative, average product does not go to negative, because it won't, because the total product is never negative. Yeah, marginal product can be negative because it is showing the change. Change can be negative, but the total product together, even if it is falling down, it can maximum be 0 if they start stop operating, but it cannot be negative, right? So a total product is an absolute number, so it cannot be negative. It's a non-negative form. Now, therefore, average product will never go to a negative point. And hence, as we observe here, it is increasing and it's then decreasing. You can keep your average product curve something like inversely U-shaped curve, average product, and inversely U-shaped curve. Yeah, you can write here as APL, right? Over here is it's L, over here it's Q, right? Now, if we put, this is labor yeah, L. If we now plot marginal product, what we see in marginal product, again it increases. See, both of them are at 100 and then average product is at 125 and it goes high 150 and it falls very fast, So the marginal product at the very initial stage will grow faster than the average product, will grow faster. So it can start from the same point, but it grows faster than the average product and then it comes down maybe till the negative point where it is like 400 to 380, that minus 20, it goes down to minus 20. So if my average product is inversely sloping, my marginal product is also inversely sloping, but the slope is steeper for this marginal product curve. If I want to keep them together side by side and try to analyze what happens, I can observe few things. Number one, when marginal product equals 0, when marginal product equals 0, TP, total product, is at its maximum. Yes, at this point marginal product, if I plot it here, maybe if I plot it here, maybe it's something like this at this point. At this point, my marginal product goes to 0 and the total product is at its maximum. Number 2, when my marginal product is greater than average product, when at this point, when my marginal product, you can see at this area, when my marginal product is greater than the average product is increasing. Average product is increasing. When my marginal product is greater than the average product is increasing. So I will say average product is increasing. Third, when my marginal product is less than the average product, when my marginal product is less than the average product, my average product is decreasing. At this point, right? My marginal product is less than the average product and we can see my average product is decreasing. Anyways, and when marginal product equals average product. When marginal product equals average product, my average product is at its maximum. So you can keep it like this, something like this. At this point your average product is maximum. Yes, at this point when marginal product is equals to your average product.